Hello all. So as a continuation of my lecture series, and now we are going to discuss about the subject power system analysis. So in power system analysis, as we all know, we will be having 5 units, in which first unit will be representation of power system. And second unit deals with the short circuit studies like line to line faults, line to ground faults, and double line to ground fault. And in unit 3, we will be discussing about the load flow studies, which the problem was solved using Gauss-Seidel method and Newton-Raphson method, along with the algorithm and the flowchart. So in unit 4, we will be discussing about the economic load dispatch and unit commitment, which is very important in today's world. And in unit 5, we will be learning about the stability studies, in which we will be using swing equations and modified Euler methods. So these are all the topics that we are going to discuss in this unit in the upcoming videos. So as the first topic and introduction, in the representation of per unit power system, the first topic will be per unit system. So before we going into the subject, we will discuss what is a system. A system is anything which we give as an input, it will give some output using some subcomponents. So this system can be defined as, it is a collection of many subsystems in order to perform a process. This is what we call it as a system. So when we come to power system, we can tell like if we get some output as a power and input is power, then we call that system as power system. So in power system, we will having what are all the subcomponents is generation, transmission and distribution. So generators, transmission lines and distribution side are the subsystems. So this is the basic about the system, power system and subsystems. So what is the need for this? What is the need for a power system and what is the need and how we have to satisfy the planning is the main thing is we have to so this is what is the representation of the power system, in which the power is generated. So power generation station is there. From there it is transferred to the main transmission line where we step down transformer is used, and that from that step down transformer it is transferred to substation through transmission lines, which is also called as electricity poles. And from that substation we can again step down to 50 kV distribution transformer, and from that distribution transformer we will be having two types of end users. One is commercial end user and another one is domestic. So when we go with commercial, it is 3-phase and it is also like industrial loads. When we come for domestic consumers, what is the line that we use in our homes? So for example, it is 220 volt power line. So between that we will be having breakers and switches. So this is what is the structure of the power system, where we have a generation station, transmission station and a distribution station, distribution part. Okay. So with this, we will go with the need for planning and the generation. So the generated power should be generated with respect to the demand. For example, if we take an area in which it has 100 houses, so we have to monitor the demand of that particular area and that particular generation or transmission to be done from the input side. So since we cannot store AC anywhere, AC voltage cannot be stored like DC, so we should have a proper planning on meeting the demand. So we have to continuously supply the required voltage to the consumers, either it may be commercial or domestic. And the second important part is protection. So in which we have to use a proper circuit breakers and proper fuses in order to avoid fault happenings in the commercial and domestic places. So if there is a fault, then there should be a proper guidance for the people to ensure that the fault is cleared as soon as possible. That is why we people are talking about SCADA and automation, like wherever the fault occurs, so it can be automatically detected and informed to the EB. So for that, they will take the continuous action in order to rectify the faults. So in order to have a smooth and a good electricity transfer, we should have to maintain planning and the operation, and that demand should meet the generation. So this is the basic introduction of the power system, and in the upcoming videos we will see in detail about the power system analysis and need for analysis. Thank you.